And now we go on to power series. And basically with power series, you have a series where n is going from 1 to infinity, and then x is a variable. And what number or numbers can x be so that this series still converges? So we could use, yep, you guessed it, the ratio test. So the ratio test, not only do I like it because it creates some fun algebra and things cancel and stuff like that, and we get to use L'Hopital's rule, but then at the end it says if it's less than 1, then it's going to converge. And if you have some x value left over, then you would know, okay, x is less than 1, that's the possibilities for x. So that's the general goal. There are a couple more details. So you take the limit as n goes to infinity. First of all, replace all of the n's with n plus 1. So this would be x to the n plus 1. On the bottom, we would have 2 to the n plus 1. And then times n plus 1 being squared. And then divide that by the original function, and since the original function is a fraction, you could just go ahead and invert and multiply. And then one small detail, which I don't often pay attention to, but we need to now, is that technically all of this is supposed to be in absolute value. So because x could be positive or negative, we now do need to pay attention to the absolute value. Previously I didn't, because these are all positive numbers. So when we only had n, I never really paid attention to the absolute value. But since x could be positive or negative, we do need to use the absolute value. And then just get you a red pen and do some canceling. Like this 2 to the n, we'll cancel this 2 to the n, still leaving a 2 on the bottom. And this x to the n will cancel this x, so leaving just an x to the 1 on the top. So we've got the limit as n goes to infinity. On the top we have a single x and a single n squared. On the bottom we've got a 2, and then if you multiply this n plus 1 squared, that's going to be n squared plus 2n plus 1. And then basically the n squared on the top and the n squared on the bottom balance each other out, and those are going to become a 1, or more formally you could do the L'Hopital's rule. So the x, you just ignore it as you do the L'Hopital's rule, because it's the n that's going to infinity. So the x will just sit there and mind its own business. And then on the top, take the derivative of n squared, so that's a 2n. And on the bottom, the derivative would be, this would be 2n plus 2. But then you need to multiply that by 2. So 2n plus 2, or I guess you could leave the 2 on the outside and then say in the parentheses, I took the derivative is 2n plus 2. And that way these 2's can cancel. And then do L'Hopital's rule one more time. I forgot to write it, L'Hopital, shouting out respect to L'Hopital. And the derivative on the top will just be a 1. So we have x times 1. And the derivative on the bottom will be 2. And then this is the ratio test. So this converges as long as it's less than 1. Since the n is now gone, we don't need it anymore. And so we just have, we've got the absolute value of x over 2 is between, or excuse me, is less than 1. Or you can rewrite that without the absolute value and say x minus 2 is between a negative 1 and a positive 1. And then just multiply by 2. So if you multiply each of them by 2, it's going to say that x is between a negative 2 and a positive 2. Now, there's one other technicality, and that is, so are either of these allowed to have an equals? So let's see. Also in the directions, oh, okay. So it said find the radius of convergence. So what I just said, you can ignore that. That would be if this said interval. So if it said interval, then you would have to check, can x equal a -2? Can x equal a +2? Because maybe if it said interval, the answer would look like this. That yes, you could have the -2, but no, you can't have the +2. Maybe something like that if it said interval. Since it said radius of convergence, then we're actually done. So this has a radius of 2, because basically you've got 0 in the middle, and then you go out by 2 in each direction. So that means that the radius is equal to 2.